We are now going to use Descartes' rule of signs. And it's really nice to know this one because it helps us even more than the possible real zeros in limiting how many numbers we actually have to look at. And so remember, we talked about the variation of changes, where if we have a function like f of x equals 5x cubed minus 2x squared minus 3x plus 4, we talked about the fact that it goes from a positive to a negative to a negative to a positive, and the variation of this is how many times it changes. 1, 2. Now here's what's really cool. What Descartes' rule of signs says is that the variation in signs, the variation of signs of the original, is how many positives you get. So the number of positive real or rational zeros, let's write it that way, is 2 or less than that number by 2 each time until we either get to a 0 or a 1. So this says that there are either 2 positives or there's no positives. And we'll talk in the next section about why there might be fewer, but it's always fewer in pairs. Now that's the rule for positive. Positive zeros come from counting the variations of x of x. Count variation of the original function. The negative zeros, though, the possible number of negative zeros, count the variation of f of minus x. So if we take f of minus x, that's going to give us 5 to the minus x cubed minus 2 to the minus x squared minus 3 times minus x plus 4. And I want you to notice something. A negative to an odd power will stay negative, but to an even power will become positive. And notice now that the only ones that changed signs were the odds. Only changed the signs of odd-powered terms. And if you do that, then you don't even need to write it out. You can just look at the odd ones and just change them. You don't need to write this step out. You can jump straight to here. Well, this goes negative, negative, positive, positive. So I'm looking at this, there's only one variation. So this says that the number of negative rational zeros is 1. Notice if I subtract 2, that goes negative, so there's 1. And this, what's really cool is there's only 1, which means I know I have to find a negative rational zero. There's no way that there's not one because it's 1. Likewise, if I found a positive 1 up here, there can't be 1 up here, so I know there has to be another 1, and that tells me to keep looking. Okay, so let's look at another example. Suppose that p of x is equal to 2x to the 5th minus 5x cubed plus 3x squared plus 2x minus 1. And all I want to do is know how many positive zeros and how many negative zeros I have. That's it. I don't want to know what they are. I don't know what they could possibly be. I just want to know how many positive and negative zeros there are. So we're going to start with the positive one. We just take the function as it is, and we count the sign changes. There's 1 sign change, 2 sign changes, 3 sign changes. So there's a possibility of 3 or 1, and I stop at the 1. But this is how many positive zeros there are. So there's at least 1, but I can find up to 3. On the negative case, we start by changing the signs of the odd ones first. This gives me minus 2x to the 5th plus 5x cubed plus 3x squared. Notice it's even, so I don't change it. Minus 2x, it's odd, so I do, and minus 1 constants never change. So this goes negative, positive, positive, negative, negative. And so here I get 1, 2, and only 2 variations. So there are either 2 or 0 negative zeros possible in this function. And if I were to go any farther than this, I'd say, hey, I'm going to start looking for positives because I know I can find at least one. And once I find it, then I can deal with the simplified form to look for others. But that's how we use Descartes' rule of signs. Just start by counting the variations of signs in the original, then look for the variation of signs in the changed, where only the odds change, and make sure you're decreasing by 2 each time to get your answer.